Hello, in this video we will use one of the animation exercise we did before, packet encapsulation, to demonstrate how the protocols will work when a computer transmits information or data packet to another computer. Let's start this module here. Now here's one of the local computers that want to transmit data packet to another computer who is sitting in a different local area network. Both local area network have their own router, which is like a gateway that connect this local area network to the wide area network or to the internet. Now when this computer sends out its data packet, let's see how the protocols work. First of all, the local computer have to process the data packet with certain application. So at the application layer, there are certain protocols will wrap the data packet with additional information. For example, if this computer using a browser to visit certain web page, then data packet is prepared for travel through the network by HTTP protocols. Next, at the transport layer, TCP transmission control protocol is added to the data packet to protect it from loss of data. At the network layer, IP Internet Protocol is added to direct the packet to its intended destination. Then at the data link layer or in the Ethernet, the MAC address is added to the data packet. The MAC address is the unique physical address of the machine that being added to the data packet to tell the route exactly which workstation sent this packet out. Now if you think of the OSI model, you will find that when the data packet being sent out from a local workstation, it went through layer by layer in the model, and in each of the layer there is certain protocols adding additional pieces into the data packet. You can see it's wrapped layer by another layer and then by another layer. And this is not all, because this basically just represents what happened in the Ethernet from a local workstation to its own router. When this data packet be ready to send out of this local area network, there is additional information being added by the other protocols, and that will create the entire frame that's transmitted through the wide area network or through the internet. Now let's take a look at data packet captured by Wireshark. We will find all these layers and the protocols in a Wireshark data packet too. Here is the Wireshark capture we did when we visit the website httprecipes.com. I have filled it with HTTP protocol, so it's only show the HTTP packet. And the first packet we have here is a GET message, and then the next one is an OK message, which is a response to the GET request. Let's take a look of both data packet here. First, the GET packet. If you look at the packet detail sections, we can look at from the bottom to the top. From the bottom, we have Hypertext Transfer Protocol because we are using a browser visiting a website. So HTTP is the protocol we use at the application layer. If you expand it, you will see that it's giving you information like which HTTP version we are using, what is the user agent, which is the browser, Mozilla 5.0 and Firefox 34.0. And there is a accept application, which is the text HTML application, accept the language is English, and the other information. The request to this website or this server. If we go up one level to transmit control protocol, that is what we use at the transport layer, and it provides the source port, destination port, and remember that the TCP is to make sure that the data packet will not get lost. So some information like sequence number, acknowledge number, flags, and checksum, all of them are used to make sure the data will not get lost. At the Internet Protocol level, It provides the source IP address and the destination IP address. The source address refers to our local computer, and the destination address refers to the website server that we visit. And this two address is to make sure that we can send the request or any other data packet to the right destination. Go up. This is the Ethernet packet. It provides the MAC address of the source computer, which is a local computer. The first part is the device name, and then the second part in the parentheses, this is the MAC address, the unique physical address of our machine. And remember that in the Ethernet, we are sending the data packet from the local computer or one of the workstation to its router. So the device name and the MAC address are for our router in a local area network. Last but not least, on the very top part, we have the frame information. This part includes the length of the frame, which is consistent with the length shown in the packet list. It shows the interface type, it shows the arriving time, and some other times that you can use to track the data packet, and a lot of other information. Now let's take a look at the second packet here, which is the return OK message. So again, if you click to it, this basically gives you everything: the frame, the Ethernet, the IP layer, the transmission control protocol, and HTTP level. And what's more, under HTTP is the inline-based text data, which is the actual web page information sent from the server to our local computer. So you will see that this is the HTML code for the web page that we are visiting. Here I also want to show you how to read the package bytes in hex code view. Each of the hex codes here represent 1 byte or 1 character in the data packet. Let's still use the first get packet as the example, selected from the packet list. And this middle window here shows the detail of this packet. If you select the frame, that's highlight the whole packet byte. And the Ethernet section, including the MAC address of the source computer and the MAC address of your router, as well as the code for Internet Protocol. Next, in the IP section, if you expand it and click to each of the detail, you will find that certain bytes or character here respond to the detail information here, like version is 4, and the head length is 20 bytes, and the total length will be the next 2 bytes, and identification will be 2 more bytes, and the flag, fragment offset, time to leave, protocol, TCP, and header, checksum, source, destination, and so on. Next, in the transmission control protocol, the same thing. It will give you the bytes that respond to each part of those information here. Now specifically, I want you to take a look at the hypertext transfer protocol. Here we are sending out the GET requests, which is respond to this part in the code. And if you specifically want to get the words GET, select the words GET here in the last column, which represent the characters in the message, and that corresponding to the 3 bytes in your code. And if you want to count the numbers, you will know that each line here are 16 bytes. So 3 lines that are 48 bytes, 49, 50, 51, 52, 53, 54, and the words GET starting from the number 55th byte. At the very end of this bytes, you will see the code 0D, 0A, 0D, 08. That indicates the end of your HTTP protocol message. Similarly, if you go to the returned OK message, you will see each part of it. You will see hypertext transfer protocol in the code. And the code also includes the line-based text data, the actual web page that has been transmitted from the server to our local computer. And right before the actual text data, you will see the last few characters or the last few bytes will be ODOA, ODOA. That's again represent the very end of the HTTP protocol. Then from here, the characters shows doc type HTML publics. That means this is the start of your HTML code for your web page. And then at the very end of it, it shows \HTML. That is the end of your HTML code for the web page. The other thing I want to show you is sometimes when you try to capture the data packet, your GET message and OK message may not sit next to each other. For example, if there is a lot of web activity going on your computer, then what the Wireshark can capture might be a lot of GET messages, a lot of return OK messages, and they're all mixed to each other. So the safe way for you to find the right track is when you find one of the GET message, you can right click to it and use follow TCP stream. Click to it. It will show you a user-friendly version of your message. First is the GET message, highlighted in pink. It shows you all the characters in a more user-friendly way. And then followed by the corresponding returned OK message highlighted in blue, and you can see that it's also showed in a reader-friendly way, as well as the actual HTML code for the web page that you have been visiting. This will be the easy way to read your TCP stream.